Hi everyone and welcome back. So we are on day 2 of limits to infinity. So make sure you're sticking around and paying attention to these lessons. Day 2 is still new material. This isn't actually just further practice from the previous lessons, so don't skip it. All right, so let's get started. Now we're going to be talking about evaluating limits to infinity. So for the first example, I give you evaluate the following limit as x approaches negative infinity. Now, when we approach infinity or negative infinity, we aren't going to just start plugging in like this. We're not going to do negative infinity squared minus 2 times negative infinity minus 5. Because what is infinity? Infinity is just a really big number. Or in this case, a really, really small number because we're going towards negative infinity. So we're not going to be plugging in directly here. You never plug in positive and negative infinity. It's more of just an evaluation of checking to see what's going to happen. So if I have negative infinity being squared, well, that's a really big number. I now have infinity squared. And now if I have infinity squared subtracted out from twice infinity, minus 5, well, this is still just going to be infinity. So again, I'll just repeat that. If I were to plug in, if you were to think about it theoretically, if I have negative infinity squared, well, now I have infinity squared, and this is negative 2 times negative infinity plus 2 times infinity minus 5. Well, I just have a really big number, so it's going towards infinity. That minus 5 is insignificant. It doesn't really mean much because we have such a huge number here. Okay, well, let's take a look at example 2. I have take the limit as x approaches now positive infinity for the following. Now, the way that we are going to be evaluating these limits when they're approaching infinity is we look for the term with the highest degree in the denominator. And now in this case, we're looking at x squared. So the way that we're going to evaluate this is we're actually going to divide every term by x squared. Every term by x squared, by doing this, we're really just dividing out by a form of 1. So I'm going to rewrite this as the limit as x approaches infinity of 7x over x squared minus 5 over x squared. Remember, limits to infinity, we're just evaluating the behavior. And then 2x squared over x squared. So I'm going to simplify this. This will be the limit as x approaches infinity of 7 over x minus 5 over x squared all over 2. Now, if you think about it, a number that approaches infinity, if it's in the denominator, and we actually did this in our previous lesson, if you guys remember, we had numbers like 2, 5, 10, 10,000, etc., and it's going towards infinity. And then we were looking at the fraction 1 over x. So if I have 1 over infinity, right, if we're going all the way to 1 over infinity, remember we said that that's equal to roughly 0, because you're doing a really small number on top, so 1 divided by a huge number on bottom, you're approximating that to be 0. So right now, as my limit approaches infinity, this term is going to go to 0. And now I have it over infinity squared. Well, this term is also going to go to 0. So I have 0 minus 0 all over 2. So this limit is going to 0. All right. So what I just did with dividing by the degree, the term with the highest degree, we're going to be doing a lot of practice with that. So that's actually going to be one of the first things that we're going to be talking about. And if you guys remember, we got to bring back that knowledge of the horizontal and vertical asymptotes with top heavy, bottom heavy, and equal heavy. So be keeping that in mind. Okay, let's take a look at exercise 1 here. So for exercise 1, I want you guys to graph this on your calculators. And we're evaluating this limit as x goes to infinity. So on your calcs, I want you guys to plug this in. Go to y equals, and I'm going to draw out the graph too. Okay, so I just sketched out the graph, and I actually took a look at the table. I went into my table to see that as x is getting really large, I've got numbers like 1.92, 1.35, 1.94, etc. I can tell that those numbers are all getting really close to 2. So what we notice is, well, the limit in this situation as x approaches infinity is going to be 2. And now I want you guys to think back to horizontal asymptotes. When we learned about horizontal asymptotes, We talked about bottom heavy, equal heavy, and top heavy. In this situation, what would this be categorized as? This is equal heavy. The degree on top is equal to the degree on bottom. So what I'm going to do is I'm going to isolate that fraction. I'm going to look at just this. So I'm going to take the limit as x approaches infinity of 6x squared over 3x squared. The x squareds are going to cancel, and I'm left with 2 because this is equal heavy. Remember, guys, when we talked about horizontal asymptotes, because it was the same degree, we take the ratio of the leading coefficients. So in this situation, when we're taking a limit, as x is approaching positive or negative infinity, you take the ratio of the leading coefficients, and that's going to be your solution for the limit. All right, so let's actually do some practice with this. So keep in mind those horizontal asymptotes. When the degree on top is equal to the degree on bottom, we take the ratio of the leading coefficients. So let's take a look at a few examples here. So for my second exercise here, we're taking the limit as x approaches infinity. I already said we're going to be doing these where it's equal heavy. So we're taking now the ratio of the leading coefficients of the fraction. So I'm going to rewrite this out as the limit as x approaches infinity of 2x squared over 3x squared. Right? Because we're talking about limits to infinity, this is useless information. It's not significant, so we don't include it. So we're taking the limit as x approaches infinity of 2x squared over 3x squared. The x squareds cancel, and I'm left with 2/3. So I would have a horizontal asymptote at 2/3. It's taking the ratio of the leading coefficients back to that horizontal test. Okay, let's take a look at exercise 3. Again, this is equal heavy. Because this is equal heavy, we're going to take the ratio. So I'm going to write that down. This is equal heavy. We take the ratio of the leading coefficients. Okay? So we take the ratio of the leading coefficients. And let's actually highlight that there. So we know already this is going to be 2 over -1, which is -2. So my limit as x approaches infinity will be -2. All right, guys, why don't you try exercise 4 on your own? Now, you should have noticed something for exercise 4. I don't like the order. I'm going to rewrite this. That way my leading coefficient has the highest degree out front in the denominator. So I'm going to rewrite this as the limit as x approaches infinity. I'm going to leave the numerator as is. Denominator, I'm going to rewrite this as -2x cubed plus x squared. Be careful, guys. The negative is attached to the 2. It's not 2x cubed minus x squared. This would be wrong. All right, negative is attached to that 2x cubed, and we have this has got a plus out front for that x squared. All right, again, just taking the ratio of the leading coefficients here, which I'm looking at my terms here as that 4x cubed and the -2x cubed. The ratio is 4 over -2. So my answer is -2. Again, I have a horizontal asymptote at -2. So guys, when we take the limits of degrees that are the same on top and bottom, these are actually the easiest ones to do because we're just taking our knowledge of what we have learned from horizontal asymptotes. It's equal heavy, ratio of the leading coefficients. Exercise 5, I forgot to put a problem in here, so if you want to make up your own, go to town. Now we're going to take a look at some more difficult cases. Not really too much more difficult, but just changing it up now. Now we're going to take a look at when the degree of the numerator is smaller than the degree of the denominator. So now we're going to be looking at when it's bottom heavy. And again, if you guys remember from when we talked about horizontal asymptotes, when you're bottom heavy, the horizontal asymptote is at y equals 0. That's it. It's as simple as that. Because it's bottom heavy, horizontal asymptotes at y equals 0. So the limit, as we're approaching negative or positive infinity, so we'll write that here, the limit as x is approaching negative or positive infinity is 0. That's your big takeaway here, when the degree of the numerator is smaller than the degree of the denominator. So let's take a look at our first case. And guys, you can graph these. You'll see this for yourself. If I have the limit as x approaches infinity of 5x over 5x to the fourth minus 4, well, this is bottom heavy. X to the fourth is on bottom. We just have an x on top. So our limit is going to approach 0. That would mean, again, you got that horizontal asymptote at y equals 0. Remember, guys, limits talk about end behavior. So when we're approaching negative and positive infinity, we're talking about the end behavior. So this limit is approaching that horizontal asymptote at y equals 0. And I'm actually going to sketch this out for you in case you don't believe me. So this is what the graph looks like if I were to graph it. And if you notice, there's your horizontal asymptote at y equals 0. All right. Again, we're checking that end behavior. For exercise 6, it's the same exact thing, guys. This is bottom heavy, right? It's bottom heavy. So we're looking at the x squared because it's bigger than the x on top. So the limit as x approaches infinity is going to be, again, 0. And as well, you can also sketch this to see for yourself that your horizontal asymptote is going to be at y equals 0. So bottom heavy, not so bad. Whenever you see that the denominator has a higher degree than the numerator, it's going to 0. When we were talking about equal heavy up here, so equal heavy as x approaches infinity or negative infinity. So this is for equal heavy. We said we take the ratio of the leading coefficients, which is what we did when we were talking about horizontal asymptotes from the beginning of the year. And now let's take a look at our last case. Now what happens when the degree of the numerator is bigger than the degree of the denominator? So this is going to affect what we're doing a little bit differently here. So our rule of thumb here, when we're taking a limit, when the degree on top is bigger than the degree on bottom, we say as x approaches infinity or negative infinity, it's going to be positive or negative infinity depending on the leading term. So now this is a little different, new information here. So again, as x approaches positive and negative infinity, the result will end up being positive or negative infinity. It's just going to depend on the leading terms. So what we're going to do, and let's take a look here at exercise 7. If you remember what I said in the beginning of this lesson, I'm going to go all the way back up here. Remember when I said we can rewrite this by dividing everything out by the term on bottom with the highest degree? We can do that for all limits. That's true for identifying for all limits to figure out what the end behavior is going to be when we're talking about limits that go to positive and negative infinity. So I'm going to do that here. Doesn't have to be just top heavy, bottom heavy, equal heavy, etc. We can do this for all limits. So I'm going to divide everything out by the highest degree that's on bottom, which is x squared. So I'm going to rewrite this as the limit as x approaches infinity of x cubed over x squared all over, this is 4x squared over x squared. And what did I have written here? And then plus 3 over x squared. You're going to see that I'll only have one x left up in the numerator. These x squareds cancel, so let's rewrite. We have the limit as x approaches infinity of x over 4 plus 3 over x squared. Now, we can identify from the end behavior of this. Well, let's look at the denominator here. I have 4 plus 3 over x squared. Now, this x squared here, as x gets huge, this whole term is going to go to 0. So I have x over 4 plus 0 as the limit as x approaches infinity. Well, infinity divided by 4 is still going to be infinity, so this is tending towards positive infinity. All right, again, I'll say that. If I were to plug in x here to be infinity, infinity over 4 is still infinity. Like a huge number divided by 4 is still going to be a huge number. So we're going towards positive infinity. All right, I want to take a look now at the next exercise, where again, this rule of dividing by the highest degree with the term attached to every term in the expression is valid, and it's going to help us identify whether the limit is going towards negative infinity, positive infinity, etc. So, because my highest degree in the denominator is x squared, so the highest degree attached to the term is x squared, I'm going to divide everything by x squared. So I have 2x cubed all over x squared, all over 3x squared over x squared minus 4 over x squared. I'll be left with just an x in the numerator here, as well as the 2. And then here, these x squareds cancel. So I'm going to rewrite the limit as x approaches infinity. And I have 2x all over 3 minus 4 over x squared. Well, again, let's identify the end behavior. As x is approaching infinity in this denominator here, 4 over infinity, remember what we said, that's going towards 0. So really I have 3 minus 0 in the denominator. So if I were to evaluate this, well, I have 2 times infinity, which is going to be infinity, all over 3. 2 times infinity over 3 is still infinity, so this is going towards positive infinity. All right. I want to take a look at a few of these now mixed, and we're going to apply this idea of dividing everything out by the term with the highest degree for all of these problems. It doesn't matter whether it's top heavy, bottom heavy, equal heavy. This is going to work every time. And if anything, I really think this allows you guys to see what's going on with the limit. So let's compare these limits, finding the limit as x approaches infinity for each of these functions. Now, if you want to pause the video here, I think that would be a great idea. I'm going to be tackling all of these questions by just dividing by the term with the highest degree for all of them. So I would like you to practice this with the same exact method that I'm about to do, rather than just going by the rules we mentioned up top, because I really want you to be able to see why these limits behave the way that they do. And we'll compare our answers shortly. So pause the video here. All right, so I just went through part A for us. We're taking the limit as x approaches infinity. I divided everything by the highest degree attached to the term in the denominator of that x squared. So everything got divided by x squared. As you could see, I simplified it in this step here. And I noticed that, well, as x approaches infinity, 2 over infinity is 0. 3 over infinity squared is 0. And I have in the denominator 3 plus 1 over x squared. And 1 over infinity squared is also 0. So I have 0 plus 0 over 3 plus 0, which is just 0. Which you would have known already based on our rules of those horizontal asymptotes again when we talk about end behavior. Because this is bottom heavy, you know that there's going to be a horizontal asymptote at 0. All right, let's take a look at B and C. Again, pause the video here and check your solution with mine. Alrighty, and here's your solution for question letter B. I took the limit as x approaches infinity. I divided everything out by the x squared term, because that's the term with the highest degree in the denominator. Everything gets divided out by that x squared. I simplified, and that's what this line looks like after the simplification. And I noticed that I have negative 2 plus 3 over x squared. Remember, we're talking about end behavior here. 3 over x squared, as x is getting huge, and we're dividing a small number by a huge number, this entire term is going to go to 0 as x approaches infinity. Similarly, we see the same thing for the 1 over x squared. I have 1 over infinity, so this is going to be 0 again as x approaches infinity. So really, I have 2 plus 0 over 3 plus 0. Oh, sorry, negative 2. So my final answer is going to be negative 2 over 3. All right, so I would pause the video here, guys, and give letter C a try on your own. Again, we're applying that method of dividing everything by the term in the denominator with the highest degree. So pause the video here and check your answers with me for letter C. All right, guys, so for letter C, hopefully you got the same solution as me. This is going to be the limit as x approaches infinity is actually going to be infinity because this is top heavy. But now remember I said let's disregard the rules and actually prove these on our own. So here I divided everything out again by that x squared that's in the denominator here. So everything got divided by x squared. And I simplified. So that's this line right here. So I simplified and then I noticed, well, 2x plus 3 over x squared, as x is approaching infinity here, if I have 3 over infinity, that's going to go to 0. And again, in the denominator, I have 3 plus 1 over x squared. Well, again, I have 1 over infinity squared. As x gets huge, this is going to become 0. So really what I was left with is this line right here of 2x over 3, because the rest was plus 0 over plus 0. And 2 times infinity, well, infinity divided by 3 is still going to be infinity, which is why my answer is just infinity. Alrighty. So you guys have now actually seen every single one of these problems in terms of bottom heavy, equal heavy, or top heavy. Now I have just some mixed practice for you guys. If you want to go through some of these, maybe try some on your own. I'll walk you through a few, of course. All right, so I'm actually going to go through these problems with you, and you can check them on your own. You can pause the video and just fast forward to see if you got the same solution as me. Totally up to you. So for this first limit I see here, for the first one, I actually immediately noticed this is top heavy. So I can't just take the ratio of the leading coefficients. I can't just say that the answer is going to be 0 because this is top heavy. So that means we actually need to do some work and evaluate this limit. Now, different from what we've done before, now we're approaching negative infinity. So we're going to write, and let's do this together. We have the limit as x approaches negative infinity. Well, I'm going to use my method of dividing everything out by the term with the highest degree in the denominator. So I'm going to rewrite this as the limit as x approaches negative infinity of 4x cubed over x squared plus 1 over x squared all over 2x squared over x squared. When I simplify this, we'll have the limit as x approaches negative infinity of 4x plus 1 over x squared all over 2. Now here we just got to be careful of the signs here. Now what I'm looking at is the following. I can identify immediately here that because x is going to negative infinity, I have 1 over negative infinity squared. Again, this number is going to get really close to 0. So this is getting really close to 0. So I have really 4x over 2. The limit as x is approaching negative infinity. And this is going to be multiplied times negative infinity here. So if I have 4 times negative infinity, that's going to be a big negative number. So I'm looking at negative infinity over 2, which is just negative infinity. So that would be my solution for this problem. All right, let's take a look at question 2. Now, again, I said I'm going to be explaining through some of these problems. I'm not going to do every single one of them, but you can fast forward if you already think you have an idea of what you're going to be doing. So in this situation, again, I'm going to divide everything out by x cubed. So I have the limit as x approaches negative infinity of 2x to the 4th all over x cubed plus x over x cubed all over x cubed over x cubed. I'm going to simplify this. So I have the limit as x approaches negative infinity of 2x plus 1 over x squared all over 1. So I'm actually not even going to write this over one piece. I'm just going to be analyzing this information here. Now, x is going towards negative infinity. So 1 over negative infinity, quantity squared, this is going to 0. So really, I have 2 times negative infinity, which is going to be negative infinity. All right, guys, and that's all you got to do. So now the only difference here is we're dealing with negative, going towards negative infinity in the limits. I'm going to skip questions 3 and 4 only because these are all dealing with top-heavy limits. You can do these for practice on your own, but I actually want to skip down to questions 5 and 6. So for question 5, I want to now evaluate this limit. Now I'm dealing with cosine in here. So let's see what we've got. Well, I have the limit as x approaches infinity of the cosine of 1 over infinity. So now remember, 1 over infinity is 0. So I'm taking the limit as x approaches infinity of x times the cosine of 0. Because remember, 1 over infinity is 0. Well, if you guys remember from your unit circle, cosine of 0, that's 1. So I have infinity times 1. So really, I'm just looking at the limit as x approaches infinity of x, which is infinity. That's it. Okay, let's take a look at exercise 6 here. So now we're taking the limit as x approaches infinity. So again, we're going to divide everything out by that x squared. So I'll rewrite the limit as x approaches infinity of negative 6x squared over x squared plus x over x squared plus, minus 1 over x squared all over x squared over x squared plus 3 over x squared. And now immediately I see things that can start to cancel. So I'm taking the limit as x approaches infinity of negative 6 plus 1 over x minus 1 over x squared all over 1 plus 3 over x squared. Now guys, you should be noticing right off the bat, this goes to 0, this goes to 0, and this goes to 0. So I'm left with the limit as x approaches infinity for this function, let's say this is the function f of x, is going to be what's left over, which is negative 6 over 1, and that is just negative 6. Okay, let's take a look at a few more practice problems, and you guys should be all good to go. I apologize, question 10 here is a repeat from question 8, so we don't need to do it twice. And I also rewrote the same question for number 9, so cut off some questions there for you. All right, let's take a look at question 7, and you guys are going to come up with an example for me for 11, and you are good to go. So again, I'm going to divide everything out by the degree, the highest degree of the term attached. So I'm going to divide, we have the limit as x approaches infinity of negative x cubed over x cubed plus 4x all over x cubed all over 4x cubed over x cubed minus 2x squared over x cubed plus 4 over x cubed. Going to simplify this. So I have the limit as x approaches infinity, the limit, sorry for my handwriting here, as x approaches infinity of negative 1 plus 4 over x squared all over 4 minus 2 over x plus 4 over x cubed. Remember, guys, the limit as x is approaching infinity, here, again, this is going to go to 0 because 4 over infinity is 0, 2 over infinity is 0, and 4 over infinity cubed is still 0. So these wipe out, these are gone, and I'm left with negative 1/4, and that's my answer. All right. Last question. At the end here, I just have a little summary for you guys, just as a little recap. You can read that on your own. Really, you want to highlight over these bullet points. The first one, second one, and the third one. All right, so give an example of a limit that goes to 4 as x approaches infinity. So we have the limit as x approaches infinity. We want the answer to go to 4. So an example of a limit that I came up with was 4x squared over x squared. You could have also done, there's infinitely many options here. Limits to infinity. You could have done 4x cubed over x cubed. Okay, these are just some ideas. All right, for our summary here, just a reminder, the degree of the numerator, when it's the same as the degree of the denominator, that has a horizontal asymptote at the ratio of the leading coefficients. If the degree of the numerator is smaller than the degree of the denominator, so if this is bottom heavy, then there's a horizontal asymptote at y equals 0. And then lastly, for the third rule we talked about, when the degree of the numerator is bigger than the degree of the denominator, so now this is top heavy, then there is no horizontal asymptote. That's pretty important. There's no horizontal asymptote. The limits are at either infinity, positive infinity, or negative infinity. It depends on the signs of the leading terms. All right, guys, I hope you found this video helpful. Really important lesson I just went through, so make sure you took the time to go through it. All right, I'll talk to you all soon.